The height of a tree after being planted is modeled by this equation. In fact, h would then be a square root function. So it would increase, but by less and less each time. This is valid between 0 and 25. A and B are constants. We're then given some conditions. We're told when the height was 2.6, the height was 2.6 exactly 2 years after it was planted. So we can substitute this in. 2.6 squared is equal to 2a plus b. And then it was 5.1 meters 10 years after. So 5.1 is 10a plus b. And we've generated simultaneous equations because it's asking us to find the complete equation, finding out a and b. There's different ways to solve simultaneous equations. There's only one mark for it in this sort of pure paper without, it doesn't say show detailed reasoning. So my advice would be to use the function on your calculator. You've maybe got a ClassWiz calculator or an upgraded one or a graphical calculator, I don't know, but there should be a solver. I can only show you what I've got on mine. So simultaneous equations, two unknowns, and I haven't even worked out what 2.6 squared is, but I can just put that, wait, not in there though. So actually A is going to be X and B is going to be Y. So I'll put 2 and 1 in and then 2.6 squared here. Then 10 and 1, 5.1 squared. This gives X equals 2.40625. I would personally write it down to more than we've asked for to start with. And then Y or B is 1.9475. If you don't use your calculator, the quickest thing to do is going to be to subtract. Do the bottom minus the top, because that would simply leave you 8a on the right-hand side equal to 5.1 squared minus 2.6 squared, from which you can get a, substitute it back in to either one of them to get b, to make b the subject, 5.1 squared minus 10 times a. You could, of course, use substitution, make b the subject. I've seen people do this, but actually I'd say elimination, when you just subtract them, is going to be the best. That means that h squared is going to equal 2.41 to three significant figures times t plus 1.95. That is our model. Given that the height of the tree was 7 meters, exactly 20 years after being planted, evaluate the model. That means find out if it's any good, basically. It's worked for, well, we've constructed the model based on the second year and the 10 years, but will it carry on in that way? So my advice here would be to just substitute one of the values in. If you substitute both in, it's not going to quite work. You're not expecting it to be exactly correct. It's a model after all. So just substitute one in and find the other one. I went with t equals 20. It just seemed to make a bit more sense to put in the time and work out the predicted height. But you could do it the other way around and say, how long would it take to get to 7 meters? That's absolutely fine as well. It's a bit more rearranging to do. So when t equals 20, model predicts h squared is going to be 2. And I decided to use the full values for this. Like in science, even though if you give a three significant figure answer somewhere, you should then use your non-rounded answer elsewhere. You'll get away with it here, I think, but best practice is to do this. Times 20 plus 1.9475. Oh, sorry, times 20. So we get 50.0725. Remember, that's for h squared. So now I just need to square root. 7.0761, which is approximately 7 meters. Okay, it's 7 meters and 8 centimeters, but that's not bad. Remember, this is a model. There are going to be some inaccuracies. So evaluate the model, giving reasons for your answer. Model predicts about 7 meters after 20 years, which is a reasonable estimate, which is um, a good estimate. So the model is reliable. That would be a conclusion. I should have probably said the model predicts the tree has a height. Sorry, I've been a bit brief. Of about. Well done.